Hello friends, welcome to LogicHeap. In this tutorial, we are going to look at theory of linked list. So when we were learning arrays, firstly we looked at arrays ADT. Similarly, when we are starting with linked list, firstly we'll discuss about linked list abstract data type. As you know, ADT deals only with specifying data structure and its behavior. So linked list ADT says linked list holds a linear collection of elements. Linked list doesn't provide a random access to a node, which was the case in arrays. So in linked list, nodes can be accessed in a sequential way. So that's the difference which lies between arrays and linked list. Here we cannot do the random access of any node, whereas in arrays we can do a random access. So we know linked list is also going to hold a collection of elements. Now how it is going to be implemented in memory. Now see, linked list has a set of elements and each element consists of data and reference to the next element. That's why this diagram is looking like chain to you. See, here 1000, 2000, 3000, 4000 are the memory location. So what you do is you create a node, okay? Now this node is created at location 1000 in memory. So you'll store this 1000 at one place. This is called the head. Head is your pointer to the first node. Okay, so head, now what does it contain? It contains the reference to the very first node that you have created. So this is 1000. This is pointing to the first node which has data is 10. And what you will do is you will create another node. Let's say its position, its location in memory is 2000, its address is 2000. So in the reference section of the first node, you will store 2000, which is the reference of second node. So that's how you progress. Now you'll move to the second node. Here data you'll store as 20, and then again you'll create a new node and its address you'll keep in the reference section of your second node. So let's say this is 3000 this time. Then you come here. Here you'll store 30. Again, you'll create a new node and its address you'll keep as 4000 in the third node. Then you'll move to the last node. Since you don't want to store more elements after it, what you'll do, you'll store data as 40. And after that, you'll store none in its reference, which indicates that there are no further elements to be added. So this is how you create a linked list. Two important nodes. First is the head, which is the pointer to the first node, and last one, it is called tail node. So head and tail. So you can see here we are not storing the elements contiguously. In fact, these are randomly located anywhere in your memory location. It's just that you should form this chain that the first node should refer to the second, second should refer to the third. That's why it is called linked list. Now, what are the benefits of linked list over array? Anyways, both are going to store the collection of elements, right? So what's the difference between those and what is the benefit of linked list over arrays? So when we were creating arrays, the size of your array was fixed. Though we were creating dynamic arrays as well, in that case also the size was fixed. Just you were creating a bigger array, but size was always fixed. In case of linked list, you can have dynamic size. So that's the plus point, that you do not need to have a fixed size of linked list. You can increase its size, like you can have dynamic sizing here. Second is insertion and deletion were very expensive in case of array. Suppose you wanted to do some insertion, you were moving all the elements to the right, you were making a room for the element, and then you were inserting a new element here. Similarly, for the deletion, you were moving all the elements to the left, which were after the index, and then you were, and that's how you were deleting the element. So insertion and deletion were kind of order of n operations. Here, in case of linked list, you'll see when we are going to see the operations of insertion and deletion, you'll see that These are very faster operations as compared to array, and it provides us the ease of insertion and deletion. So that's the benefit. First is dynamic sizing, and insertion and deletion are inexpensive operation case of linked list. Though it has these good properties, there are some limitations as well that comes with linked list. So first is random access is not allowed. So accessing here is not a order of one thing, which was in the case of arrays. If you want to access an element, you can access it using an index. There's nothing like that in linked list. You'll have to go sequentially through the linked list, and then you can access any particular element. So random access is not allowed. And second is more memory is required for storing the pointers. So with every data, we are also storing the reference to the next node. So that's why there's more memory consumption to store the references. So there are upcoming three tutorials. First, we'll be seeing the implementation of linked list in Python, and we'll also see how we can traverse a linked list. In the second tutorial, we'll see how we can insert new elements at the beginning, in somewhere between, and at the end. So these are three cases for the insertion. If you want to insert an element as the first node, or somewhere in between, or at the end, like you want to append a new node. Similarly, we'll read all the cases of deletion when we want to delete the first node, we want to delete the last node, or we want to delete any node somewhere in between. So these are the cases that we are going to take one by one in upcoming tutorials.
Thank you so much, guys, for tuning into Logic Heap. If you like this video, please don't forget to like, share, and subscribe.